My name is Martin Platt. I'm co-founder of Ambasat and we are located in North Allerton in North Yorkshire.
Here in the wake of dawn I see you shine.
My name is Simon White. I'm the head teacher of Ambasat School. I'm also the CEO of Vision Academy Learning Trust.
Heartbeat, I fly so much higher, fly so much higher.
So this is the Ambasat product called a Ambasat. So it's, as you can see, it's very small, 3,500 square. We fit 200 of these into a single 3U CubeSat.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town.
It's fantastic to see the work that Egglescliffe School have been doing through the funding that we've been able to provide through our careers programme and the space programme that the teachers and the staff and also the students have participated in at Egglescliffe School, with the view of becoming the first school to launch a satellite into space, has been second to none. And these are the types of things that we should be doing. These are the types of things that we should be doing to get young people enthused about STEM subjects, engineering, technology and science, all of those things that we want our young people to do, because that's where the good jobs are. And I just want to say that Egglescliffe have done a fantastic job in enthusing their students, putting this programme on, and I'm also pleased to play a small part by providing some of the funding to be able to get it done. So keep up the good work, guys. It's a fantastic thing, and hopefully we'll see more of it in the future.
Hi, I'm Tom. I'm in Year 9 and I'm interested in a nuclear engineering career.
I'm Ruben and I'm in Year 9 and I'm interested in IT development.
When you're working together and looking at satellite technology and everything else, you're looking at teamwork, you're looking at being creative, you're looking at being aspirational. And actually, as you're forming those thoughts and experiences, what you are doing is you're actually creating potential thoughts and directions for careers, for university courses, looking at how industry manifests itself and what pathway you could create.
My name is Beatrice and I'm in Year 8.
My name's Liam and I'm in Year 8.
I see the light inside you, brighter than the skies. Hold on, just let us escape and fly away.
It doesn't particularly matter what the STEM project is with the students. It just, whatever it is, it has to be real. You can't inspire the 21st century student with a paper bridge or with a spaghetti tower. If the students decide to build a bridge, then they have to cross it, they have to walk across it. If they decide to build a racing car, then they have to race it. If they decide to build a robot, they have to operate it, they have to program it, they have to fight it.
3, 2, 1, activate!
Even more importantly, I think, is the need to tie that in with industry experts, outside people, get outside people in to show the students actually these skills, these projects they're doing, they are needed, these skills in the real world.
I'd like it to probably scan ice structures in geography, so we know if there's any global warming increase in the world.
School children and individuals can basically build their own satellite. We provide a basic set of 8 sensors that they can use. The satellites orbit the Earth about 16 times per day. You can measure CO2, you can measure UV radiation, you can measure temperature, humidity, volatile gases, and GPS location. Even though they're at 310 kilometres, it's a very, very small atmosphere up there, so there's that drag all the time. So after about between 3 weeks and 3 months, just gradually that drag becomes more and more, and they eventually burn up in the Earth's atmosphere, so there's no debris the end of the day, which is another good thing about them.
Because like it's not every day, so it's not just like maths, French, English. It's not like that. It's just like building a satellite. And I was really interested in that, and because when we did an IT day with engineering club, that's what I envisioned.
Like learn to code better.
A good idea for when like I get a CV or something, I can just put that on. Like, so I want to be an engineer as well.
It gives them, I think it gives them a wider range of confidence when coming to jobs, so they're better equipped and have a larger mindset for engineering and other jobs that involve technology.
Maybe to like learn something that I can't every day, so like I could come out of that and like know something that no one else wouldn't.
So these STEM subjects offer a strong basis for the children to progress and develop the mastery within each of those subjects, which then can apply and develop their wider knowledge and learning through all of the other subjects that they do. And what we need to do is to actually map that out so the children have a love of learning, but it's underpinned by STEM science, and that the children then can blossom with a broader understanding that the science, the technology, the enterprise, the engineering and the mathematics are fundamental principles.
Yeah, I think in that context, then it's giving the kids a real world experience, something that we're actually developing, using and creating in the real world. It's not something that's in a science lab. It's something that when they leave school, they're going to use in their day-to-day work.
Real world activities are essential if you want to fire the imagination of the next generation. I had a conversation with Dr. Andy Aldrin, and we discussed the need to generate enthusiasm and aspirations within our young people. And we decided then that Egglescliffe School, we would build our own satellite and we will launch it into space.
So the satellite is launched from off the coast of California on the iOS Interoperable Systems rocket. It reaches a deployment altitude of 310 kilometers, and at that point the rocket deploys the 3U CubeSat into low Earth orbit. The rocket then sort of goes back into, burns up in the Earth's atmosphere.
Ignition sequence started. 7, 6, 5, 4, 3, 2, 1.
Once we receive the signal that the CubeSat has been deployed, we then send a signal from our ground station to the CubeSat, we call it the mothership, to basically deploy the 200 Ambasats. So they get deployed, and as soon as they are deployed, they are capable of transmitting data back to Earth. So they're about 310 kilometres, their orbit's 310 kilometres. They are capable of transmitting to about 720 kilometres. Our Ambasat 3 product, which is 5 years away, is one that we're hoping to launch on rocket to Mars, and again do a similar thing, orbit Mars and pick up all kinds of different sensor information from that. So that's a longer term goal for us.